climate orbiter was on the wrong trajectory, and our checks and balances did not reveal that error.
In December 1998, NASA launched a spacecraft toward Mars. Its mission was simple: enter orbit around the red planet and study its atmosphere and climate. For nearly 10 months, Mars Climate Orbiter traveled through space, crossing hundreds of millions of kilometers toward its destination. Then, on September 23, 1999, it reached Mars and disappeared. NASA had lost contact with the spacecraft. The reason was not a mysterious signal, a solar storm, or alien world. It was something far more ordinary, a mistake in the way two terms measured force. One used imperial units, the other used metric. And somewhere between Earth and Mars, that tiny difference became a catastrophic error. So, how did one of the world's most advanced space agencies lose the spacecraft because of something so simple? And what exactly happened to Mars Climate Orbiter? This is the story of the NASA mission that got lost at Mars. But before we uncover the mystery, if you don't subscribe to my channel, just subscribe. Okay, then let's get started. Mars is a dusty cold desert world with a very thin atmosphere. This dynamic planet has seasons, polarized caps, exist volcanoes, canyons, and weather. Mars is one of the most explored bodies in our solar system, and NASA missions have found lots of evidence that Mars was much wetter and warmer with a thicker atmosphere millions of years ago. Scientists don't expect to find living things currently thriving on Mars. Instead, they are looking for signs of life that existed long ago. When Mars was warmer and covered with water, the enigmatic red planet has captivated the imagination of humanity for centuries, and numerous spacecraft were sent to explore its surface and atmosphere. But among these missions, one stands out, not for its success but for its tragic failure: the story of the lost Mars Climate Orbiter. The Mars Climate Orbiter was a space probe designed to be a smaller, less expensive way to explore Mars in the wake of 1993 and loss of the Mars Observer, and was launched on December 11, 1998 by the NASA in Florida. It was a cutting-edge spacecraft designed to study the Martian climate, atmosphere, and surface. Its mission was to orbit Mars and provide crucial data that would advance our understanding of the red planet. For months, the orbiter journeyed through the depths of space, overcoming countless challenges on its way to Mars. But on September 23, 1999, as it approached the planet for orbiter insertion, disaster struck. Mars Climate Orbiter went out of radio contact when the spacecraft passed behind Mars earlier than expected, and communication was never re-established due to complications arising from human error. The spacecraft encountered Mars at a lower than expected altitude, and it was either destroyed in the atmosphere or re-entered heliocentric space after leaving Mars' atmosphere. The mission was lost, and NASA was left relying for the catastrophic failure. But what went wrong? How could such a technologically advanced spacecraft meet such a tragic end? The answer lay in seemingly ordinary detail: unit conversion. Lockheed Martin, the primary contractor for the Mars Climate Orbiter, used English units pound force seconds for its thruster data. Meanwhile, NASA software used the metric system's Newton seconds. This error led to correct calculations of the spacecraft's trajectory during the crucial orbiter insertion maneuver. As a result, the orbiter thrusters fired with much less force than intended, causing to miss its orbit around Mars entirely. The mission was lost, and NASA faced not only the financial cost of the failure but also the disappointment of the entire scientific community, eagerly awaiting the data the orbiter would provide. According to NASA, the cost of the mission was $327.6 million total. For the orbiter and lander comparison, $193.1 million for spacecraft development, $91.7 million for launching it, and $42.8 million for mission operations. The Mars Climate Orbiter failure was a wake up call for the aerospace industry. It showed us the critical importance of communication coordination and double checking in complex engineering projects. It also highlights the significance of take to stereotype measurement systems to prevent such costly errors in the future. Unit conversion may seem like a small detail, but in the vastness of space, even the smallest mistakes can have devastating consequences. Despite its tragic end, the Mars Climate Orbiter remains a symbol of humanity's spirit of exploration. Its legacy serves as a reminder of the risks and challenges inherent in space exploration and the importance of learning from our mistakes to push the boundaries of knowledge even further. So, if you like this video, just subscribe, like, share. Bye everyone.